All right. Welcome, Bearcats. Welcome to EverQ5 2018, I guess it is. And this one's pretty cool. Like the first three parts of this problem, super straightforward, super easy. And then enter L'Hopital's rule. And L'Hopital's rule in this situation is super complicated because they don't really tell you to use it. It's you got a graph. It's weird. So with that said, it is only, well, it's worth 3 points. So if you wanted to get 6 out of 9 on this, that's probably a pretty good score. More than a 6 out of 9 is exceptional. So here we go. Part 1 says, I'm going to give you this function, and then I need you to find the average rate. So when it says, I need the average rate, be careful. Students see average rate, and they're like, oh, I'm going to use the average value function. No. If they give you the rate equation, and they tell you to find the average rate, yes, use the average value function. Remember, the average value function, the average value equation, will give you the average value of what they gave you, right? So in this situation, they didn't give you the rate, they gave you the original function. So if you want the average rate of the original function, dude, that's just the slope, man. It's been the slope for the last 5 years. So part A is just going to be a find the slope problem from 0 to pi. So let's see how they wrote their answer. So here we go. The average rate of change from 0 to pi is going to be y2 minus y1 over x2 minus x1. That's it. It's super ugly. Don't be upset. That's the way it is. Don't simplify it. Write it down and walk away. All right? By the way, and for that work, you get 1 point. Part B. So part B says, what is the slope of the tangent line to the graph at? Okay, now we got it. Now, slope of the tangent line, definitely going to take the derivative. So remember, when you find the derivative of this, this is really a product rule question. Do you know the product rule for this equation? So you have an e to the x cosine x. So remember, the product rule says that f prime of x is going to be, the first e to the x times the derivative of the second. Derivative of cosine is negative sine, plus the second, I'm going to put it over here though, right? Whoa, hold up. There we go. The second times the derivative of the first. I just switched the order of those so you can see it. Then you're going to factor out an e to the x, and you're going to get cosine x and minus sine x, right? And then you just have to find the tangent line there by plugging in a 3 pi over 2. So let's see what they did for their work for part B. So for part B, they did the derivative. There it is. So there's their derivative function, right? Just like we got, they did flip it. And then they plugged in a 3 pi over 2. So e to the 3 pi over 2 times a cosine of 3 pi over 2. Cosine of 3 pi over 2 is, of course, 0. That's correct. And then the sine of 3 pi over 2 is worth negative 1. So since this turned into a negative 1, and you already have a negative here, the answer is going to be positive e to the 3 pi over 2. So you get a point if you correctly found the derivative, and then you get a point if you correctly plugged in everything and got the values. All right, part C. So part C says find the absolute minimum value. So to find absolutes, you have to check the following things. You have to check endpoints, and you have to check critical points or critical values. So you have to check all of the places where the derivative is 0. Those are the flat spots. So if I was doing a graph, that could be like the top of a curve or the bottom of a curve. And then I have to check the endpoints because it's possible I started, then I went up, then I have to check to make sure which one of those things is going to be the least right here, right? So here we go. See what they did. I can see they already have a table. So if I was doing an AP test and I saw a minimum value or maximum value question, I would make a table. I would put the two endpoints, right? This one said going from 0. So here's my first endpoint and my second endpoint. Then I would have to find the critical values, and you'll notice their f prime equation. Remember, this was f prime up here. So they factored out the e to the x because it never equals 0, and that left them with cosine x minus sine x equals 0. So when does that happen? Well, that happens on the unit circle when the sine and the cosine are exactly the same. So that's why it's going to be at pi over 4 and 5 pi over 4. So that's the two critical points. And then they plugged them in and had to figure out which of these is going to be the least or the minimum value. Clearly, it's going to be the one that's negative, because that's kind of what happens. So one, did you set the derivative equal to 0? Did you do this statement right here? So that was worth 1 point. Did you identify the two critical points as possible candidates for the answer? And then did you actually get the answer and have all of the justification here? So this is part that and part that also. So you get a point for that too. All right, last chunk. Here he comes, L'Hopital, walking down the street. So in this problem here, it says, hey, here's what I want you to do. I want to know the limit of your function that I gave you up top divided by this garbage right here on the bottom. So, okay, I can clearly see it set up in a function that's going to say L'Hopital, right? I have a function over a function. So they're just telling you, man, is a L'Hopital's rule. So, and then they tell you that this function, remember, this is actually g prime. So I don't even know what g is. All I know is that at pi over 2, they told me that at pi over 2, it's worth 0, which is perfect. Because if that is worth 0 at pi over 2, then all I have to do is tell you that that is worth 0 at pi over 2, right? Because then I'm going to have that indeterminate form of 0 over 0. So remember, if I want to use L'Hopital's rule, I got to state that I got a differentiable function and it's in indeterminate form. I have to state that. If I don't state that, I don't get points. So here we go. By the way, you can see at pi over 2, you can see that the derivative of g at pi over 2 is going to be worth 2. I'm going to need that piece of information. I can't get any information about g. All I have is this guy, which, by the way, is 0. So here we go. Oh, wait. Is that underneath? Where's it at? What do I do with it? There it is. So here's their work for part D. So for part D, they were like, cool. All right, first of all, f of x is worth 0 at pi over 2. How'd they get that? Well, remember, here was the original function. F of x equals e to the x cosine x, right? So they just plugged in a pi over 2. And clearly, if you plug in a pi over 2 cosine of x, it turns into 0. I do need to state that it's differentiable and continuous, and that this is worth 0. So you'll see over here it says I need to state that g is continuous. I don't know why that's being specific, but that's what they want. And both of these limits, as these go to pi over 2, both of these limits are 0, because that's what gives me indeterminate form. Therefore, I can now use L'Hopital's rule. So the limit of this function over that function will give me the same answer as the limit of the derivative of this function over the derivative of that function at pi over 2. So I looked on my graph, right? On my graph, it says that g prime is worth 2. And then at pi over 2, I had to find this derivative, so I went back up to part B, right? So I went to part B, where I had the derivative, and I plugged in a pi over 2, and I got that as my answer. So if I wrote that, I get that. By the way, it says applies L'Hopital's rule. You better state that this is true. If you state that is true, you get that point. All right. So with that said, hopefully you guys did well. That's it. Till next time.